Okay, ladies and gentlemen, we're going to look at question 9 from section 3.4. It says that a black checker is placed on the bottom right corner of a checkerboard, just like they show in the picture, and the checker can move diagonally upward, which basically means as it moves upward, it can go left or right from one white square to the next. So it can do this, or this, or this, or this, that sort of thing. When we get up to this red square, it says that the black checker cannot enter the red square, so it can't do this, cannot do that. However, it can jump over the red square to the diagonally opposite white square. Okay, it can jump over it. And our job is to determine how many routes can lead to the top of the board. So here we go. We're going to use Pascal's method. There's one path which can lead to any of these squares. If it just moves diagonally up and to the left. And, well, there's only one path that leads to there because there's really no way you can come from the right. But here's where it starts to get interesting. 1 and 1 is 2 paths. 1 and 2 is 3 paths that can get to here. There's only 2 ways to there. 5 paths to here. 5 paths to here. And for the rest, well, we're going to need to deal with jumping over this red checker. So let's look at this square here for now. Okay, you can see that from the left there is one square, one path that comes from that square. There's also this number 3 here. That number 3 beneath my red line. And so 1 plus 3 is 4 paths that can lead to that square. And similarly, there's a 1 that can jump over the checker from diagonally from the left side, and there's 5 ways that from the right side that would lead to this square. There are 6 paths to get to that square. And now if we just add up pairs of numbers, we can get 1 plus 4 is 5, 4 plus 6 is 10, and 6 plus 5 is 11. So altogether, the number of ways that we can get to the top row would be 1 plus 5 plus 10 plus 11, which is 27 ways. Hope that helps.